Good morning, children. We are on to the next lecture on the chemical properties of alkanes. In the previous lecture, I have already completed halogenation of alkanes with the mechanism. Okay, so in today's lecture, I will be completing combustion, aromatization, isomerization, and pyrolysis. Okay, so with that, all the chemical properties of the alkanes will be done. Right, now combustion. It is a type of oxidation reaction. Okay, it's a type of oxidation. Now, the oxidation can be either complete or it can be, in the presence of the catalyst. Like if I'm saying complete oxidation, so basically I mean combustion. That means the hydrocarbons, for example, if I'm saying alkane, actually the same reaction is also possible for any kind of the hydrocarbon. So since we are talking about the alkane, we are focusing upon that, right? So alkanes, they burn in the presence of the excess of oxygen and they will result in the formation of carbon dioxide and water. Any combustion reaction will always result in the formation of carbon dioxide and water, right? So if I write down with the general formula of alkane, that is CnH2n plus 2, because you may carry out the combustion of methane, you may carry out combustion of ethane or whatever alkane it is, right? So plus oxygen, it will form carbon dioxide and water, right? Now when you balance it, you can balance it like this. So n carbon atoms mean this will be n, right? And if you check hydrogen atoms, it is H2n plus 2. This 2 is already there. That means this will be n plus 1. If you balance, it will be n plus 1. And for oxygen, you can just see on the right hand side, all oxygens are completed. That is n plus 1 of oxygen, and this is 2n. So if you combine them together, it becomes 3n plus 1 divided by 2, right? So this is the general formula how you can balance the combustion of any alkane. Let us write down with respect to, say, methane. Methane plus oxygen, it will form carbon dioxide plus water. Now let us see, this is one carbon atom, so this will be one only. This is n plus 1, means this is one carbon, right? Means the n value was 1 here, so it's n plus 1. That means this will be 2, right? So likewise, if you calculate, oxygen will be 3 by 2, because 3 into 1 plus 1. Okay. No, 3n plus 1 means it will be 4 by 2. 4 by 2 means when you solve, it will be just 2. It will be 2O2. 2O2. So the balance equation becomes methane plus 2 oxygen gives you carbon dioxide plus 2 water molecule. Let us try out with respect to ethane also. Ethane plus oxygen, it's going to give you carbon dioxide plus water. Apply this formula for balancing, C2. So n value is 2. N plus 1. 2 plus 1 means it will be 3. And for oxygen, so you have 2 carbon atoms, means 3 into 2, 6, 6 plus 1, 7, 7 by 2. 7 by 2. That will be the balanced thing. Okay. 7 by 2 means 3.5. 3.5 into 2 is 7. So 7 oxygens are there on the right hand side also. This is combustion. So we were talking about oxidation reactions. So under oxidation, we have done the first category, combustion. What is combustion? I told you, combustion is burning of the hydrocarbon in the presence of excess of oxygen. Okay, now let us talk about catalytic oxidation. Now what is catalytic oxidation? Catalytic oxidation means if you carry out oxidation in the presence of catalyst. In the presence of catalyst. Now, one thing you will remember in the complete organic chemistry, the sequence of the oxidation. The sequence of the oxidation is like this. If you start with alkane and you carry out the oxidation of alkane, alkane will undergo oxidation and it will result in the formation of alcohol. Alcohol further will get oxidized and it will result in the formation of aldehyde or ketone, depending upon what alkane we took, ketone. This further can undergo oxidation and it results in the formation of carboxylic acid. Carboxylic acid. This is the complete sequence. Okay. So if we want to carry out the oxidation reaction and we want to start from alkane, suppose we want to form alcohol. You will be carrying out the reaction in the presence of copper tube, and the pressure has to be 100 atmosphere and the temperature is 473 Kelvin. If these are the conditions given, you will get alcohol. The product will change based upon what is the catalyst used. Suppose from alkane we want to form aldehyde or ketone. Then we will have to use here the catalyst molybdenum oxide, 100 atmosphere and 573 Kelvin. If from alkane we want to prepare carboxylic acid, we will have to use manganese acetate. So keeping this in mind, we can write the equations easily. Yeah, one more thing. In that sequence which I told you, alkane forming alcohol, alcohol to aldehyde ketone to carboxylic acid. Suppose you start with one carbon alkane, that is methane. You will get here methanol, you'll get methanol, you'll get formic acid, and that formic acid can further undergo oxidation and this will result in the formation of carbon dioxide and water. This is the product only if you are taking methanol here. Suppose if you take methane here, methane will give you methyl alcohol will give you methanol will give you formic acid will give you carbon dioxide and water. Suppose you start with ethane will give you ethyl alcohol will give you acetaldehyde to ethanoic acid. That's it. This will not further undergo oxidation to form carbon dioxide and water. So this product beyond carboxylic acid is formed only if you have taken methane, if you carry out the oxidation of the methane. Okay, now let us write down specifically if it is one carbon atom alkane or two carbon atom, what will be the products. Suppose you have here say methane, right? And the question says you carry out the oxidation in the presence of copper tube and you have 100 atmosphere and you have 473 Kelvin. You will be writing alcohol, means you will be writing one carbon alcohol. If correspondingly you were given, instead of methane, you were given ethane in the presence of the same oxidizing agent, copper, 100 atmosphere and this temperature, you will be getting 2 carbon alcohol, that is ethyl alcohol will be obtained, right? If you were given here methane and the catalyst you were given as molybdenum oxide and 100 atmosphere and 573 Kelvin, then this will form aldehyde. That means you will get 1 carbon aldehyde, that is methanol will be obtained. If you use ethane and use the same molybdenum oxide and this same catalyst you use, then you will be getting 2 carbon aldehyde. I hope the point is clear. Suppose you want to prepare this, you are using this catalyst. Suppose you are using methane and you're using manganese acetate, you'll be getting acid with 1 carbon. If you're using ethane and you're using manganese acetate, the same catalyst, you will be getting 2 carbon acid, that is ethanoic acid. So I hope this point is now perfectly clear. This is the catalytic oxidation. Depending upon what catalyst you use, you will get the corresponding product. Clear? Moving on to the next reaction, that is isomerization. Okay, so if you take alkane with 4 or more carbon atoms, let us take with the least number, say 4. 3, you will not get an isomer. So at least say 4 carbon atom you are taking. Suppose you have taken here 4 carbon atom. You have taken butane. The isomerization can be carried out in the presence of aluminium chloride, dry HCl. This catalyst acidic medium is required. Temperature should be 573 Kelvin and 35 atmosphere. If you use these temperature pressure conditions and the catalyst, you will get the corresponding isomer of it. That means you will get with 3 carbon atom and 1 carbon will go as a branch. That means one of the isomer of normal butane is formed, that is isobutane. Normal butane can convert to isobutane in the presence of this catalyst. Suppose you take 5 carbon atom alkane. You are using the same catalyst, aluminium chloride, dry HCl, same temperature pressure. You will be getting all possible isomers of pentane. That means you'll get 4 carbon atom with 1 branch, or you may also get 3 carbon atom with 2 branches. That means normal pentane can form isopentane and neopentane. This is neopentane. These are the common names. But otherwise 2-methyl butane, 2,2-dimethyl propane. This is isomerization, right? So depending upon what alkane you take, you'll get the corresponding isomers of it. You'll get a mixture. So when you get a mixture, of course, it is not a preferred reaction because it's very difficult to separate the various isomers since the boiling point difference would be quite less. Now moving on to the next reaction, that is aromatization. Now what is aromatization? If you take 6 or more, if you take alkane, that also you can specify. If you take alkane with 6 or more number of carbon atoms, 6 or more we say, but particularly it is from 6 to 10 nearly. If you take this alkane with 6 to 10 number of the carbon atoms, then that alkane will undergo aromatization, means it will convert into its aromatic compound. For example, if you take normal hexane, then it will form a 6-membered ring, that is, it will form benzene. Let me explain with the example of normal hexane. I am writing normal hexane particularly in this form so that you get it. You are able to relate to benzene, right? This is not 1, 2, 3, 4, 5, 6 carbon atoms. This is CH3. This is CH2. This is CH2. You have CH2. This is CH2, and the terminal one will have CH3. So normal hexane, when treated with chromium oxide or aluminium oxide at around 600 degrees Celsius and 15 atmosphere pressure, will undergo aromatization. Now what actually happens in this? Okay, that we will understand. When it is undergoing aromatization, it will be forming benzene. But before that, you just see there is a bond between carbon and hydrogen atom. So one of the bond between carbon and hydrogen, that H comes out. That means if I write separately, their carbon hydrogen bond, this will break by homolytic fission. It will form one hydrogen free radical here. This also will break. So that means both these carbon atoms will get free radical. Means here there will be a free radical, here also there will be a free radical. So if I write down that intermediate step and mention, this will be now CH2, this will be now CH2, this will be a free radical, this will be a free radical. These as such are CH2s only. Okay, these are CH2s only. Plus one H2 also will be formed, because a one H from here, one H from here, those free radicals will combine and they'll form H2. So this straight chain 6 carbon atom free radical is formed. Now this free radical and here free radical, they will combine and they will result in the formation of cyclic structure, that is cyclohexane is formed. With all the corners here you are having CH2. Now what happens is, from all the carbon atoms there are one that CH bond will break. So CH one bond will break, CH. So all these will give out. So if H is coming means one H2. Then from here another H2. From here another H2. Means 3 H2s will be generated from here. And when they are removed from each carbon atom, one hydrogen is removed. So those free radicals will now combine and they will aromatize. That means it will result in the formation of benzene. It will form benzene. I just wrote this way, means the free radical can even combine this way. So you can write down double bond here or alternate. Either way it is correct. That means it is undergoing aromatization and resulting in the formation of benzene. Suppose if you take 7 carbon atom, if you are taking here say 7 carbon atom, then what might happen? Suppose you have taken here heptane. Then heptane means you are having 7 carbon atom. That means it was having 1, 2, 3, 4, 5, 6, 7. Okay, so 7 carbon atom you are taking in the presence of same chromium oxide, aluminium oxide, temperature, pressure. So then it will undergo aromatization and will result in the formation of toluene. One extra carbon here will be in the form of the methyl. The same thing is happening even here. Okay, first from here that bond will break, it will form a ring, and that extra carbon will go as a alkyl radical. Now suppose there is octane. This is normal heptane. If heptane is there, it will result in the formation of toluene. If you take here octane, if you have taken octane, then it will result in the formation of xylene. That means you may get 2 methyls either on the adjacent carbon. You may be having methyls at the different position. That means you will get here xylene. This is aromatization. Clear? Now moving on to the last reaction, that is pyrolysis. Pyrolysis means when you heat higher alkanes on heating, they get converted into lower alkanes. They can form alkenes. They can liberate hydrogen gas. So that means if you are using zinc or aluminium oxides or even silica, if you are using this as the catalyst, then the carbon-carbon bond will break. If you are using chromium, vanadium or molybdenum oxide, if you are using chromium, vanadium or molybdenum oxides as the catalyst, then carbon-hydrogen bond will break. Okay, so you'll get different products. So normally you take higher alkanes, but I am taking 4 carbon atom alkane and explaining it. Right? So the same will be applicable for 6 and all. Just so that basic understanding is there, I am taking 4 carbon atom. Suppose I have this alkane. Say I am having butane. right? So this butane, right? So suppose I carry out the reaction of this in the presence of, say, aluminium oxide, Al2O3. Al2O3 के presence में we are heating it. So the bond may break. Carbon-carbon bond has to break. So carbon-carbon bond, when it is breaking, this bond may break or this bond may break. This side is the same. So suppose let us break this bond and see what will happen. When this bond breaks by homolytic fission, it will result in the formation of CH3, CH2, CH2 free radical, and the other one you will have CH3 free radical. You will get one N-propyl free radical, another methyl free radical. Now the possibility here is one H from here will shift this side. When it shifts this side, it will result in the formation of methane. So one product might be methane. The center carbon atom now is H. So this is having one free radical. So this free radical on the carbon atom, because one H has gone, so this free radical here and this free radical, these bonds will form and it will result in the formation of alkene. So either it may form alkene, that is propene plus methane, or let us understand another reaction. I am writing with the other color to understand the next one. Okay, let me write down here. Suppose this bond breaks, that means this bond breaks. If this bond breaks, the possibility is that it will form CH3, CH2 free radical and CH3, CH2 free radical. So then the possibility here is this carbon atom, hydrogen bond may break, it may form a free radical and one H from here may come this side, make this CH3, CH3. So it may form CH3, CH3, that is ethane, and this is now CH2, that free radical and this free radical, they will combine and will result in the formation of ethene. So it may form ethene and ethane. In the same reaction, suppose the catalyst used is different. Suppose it is given in the same reaction, the butane only. Suppose it was given the catalyst is, say, chromium oxide or molybdenum oxide, and you are heating in the presence of it. Then the hydrogen bond may break. That means you may have CH2, CH2, CH3. There is again a possibility that this CH bond and this CH bond may break. When this CH bond may break, so one free radical will be generated here, one free radical. So these two will combine and may form a double bond. You may have like this CH2, CH, double bond and CH2. I hope this is clear. When I am saying this carbon, one of the hydrogen bond, this carbon, another one of the hydrogen here. So that H2 is coming out, right? So that H2 is coming out plus, now what is there? The remaining free radicals which are generated, they will combine and form a double bond. That means in this case, H2 also will be released. Or another possibility would have been that this carbon and this carbon, they carbon-hydrogen bond may break. So those two free radicals may be generated here. These two may combine with each other and may result in the formation of a double bond somewhere in the center. Got it? So with this, the pyrolysis, I think is clear. So if you can try out the pyrolysis of, say, alkane, you may try out with the pentane, hexane, that higher ones. Okay, so the concept will be further clear, right? So I have completed now all the reactions, the chemical properties of alkanes. In the upcoming videos, I will be starting with alkenes. Thank you.